unit circle with you. Okay, we're going to be using that a lot this unit. So I believe we were in the process of trying to evaluate these trig expressions by using our unit circle to figure out the point or ordered pair we should be using. And are we on this last one in the middle? I'm not sure if we did that one or not. We're on that one? Okay. So at the top of that page, we filled out this table that shows us the different relationships between the trig functions and the ordered pairs on the unit circle, like how the trig functions are related to either an x-coordinate or a y-coordinate, or sometimes both. So let's go ahead and try to tackle this first one that we need to pick up with. We want to try to figure out the cosecant value at the 4 pi over 2 radian location on the unit circle. So let's first just think about how is cosecant related to the variable x or y. Think about what is cosecant the reciprocal of. Maybe that would help you out. Yeah? Cosecant is related to y, okay, and it's the reciprocal of sine. So we would have 1 over y. So somehow we got to use the y-coordinate from the ordered pair on the unit circle. Let's go ahead and find the 4 pi over 2 spot on the unit circle. Can you describe where we're located? Can we find it? I see a 4 pi over 3. Is there a 4 pi over 2? Yeah?
You have to completely simplify it.
We can simplify it, right. 4 divided by 2 is simply 2. So this is the same thing as 2 pi. Is 2 pi on the unit circle? Yeah, we'll go ahead and find it. That's our beginning spot. If we were to do a full circle, we'd be back to where we started on that right-hand side. So we got to use the ordered pair on that right-hand or most right-handed spot. And Ashlyn told us we need 1 over the y-coordinate, which would be 0. So the cosecant value at that 2 pi spot is 1 over 0. What is 1 over 0? Yeah? Undefined. So we're taking some undefined value plus something else. Doesn't really matter what else we add to it. It's still going to be an undefined value. So that's kind of nice because we don't have to figure out the other part. Okay, we're already having an undefined value. We'll just stop there. All right. The last 3 are a little different. Notice how they're negative radian values. So this time we got to pay close attention on how we're traveling backwards on the unit circle. So if you think about the next one, the radian 2 pi over 3 on your unit circle is right here in the second quadrant. And if we always start on the right-hand side, notice how we would have had to travel through 1, 2, 3, 4, 5 points. That's if we were to travel positively. But this radian value is negative. So we have to travel that same distance backwards. Can you tell me where we would land if we were to travel 5 points backwards? Instead of going a positive pi over, or 2 pi over 3, we want to go a negative 2 pi over 3. Where would we land? Yeah. 4 pi over 3. Okay, so this value is the same as the sine of 4 pi over 3. I know negatives can get confusing for us sometimes, so maybe we'll change it to a positive. We'll think where we would land using a positive value. So let's go ahead and use that ordered pair. At 4 pi over 3, we want the sine value at that spot. So based off the ordered pair, which value would we write down? Which variable does sine represent again? Take a look at the chart at the top to help you out. Yeah. There we go. We need the y value. Perfect. All right. If you wanted to check it on your calculator, you could. You would type in sine of negative 2 pi over 3. Make sure you're in radian mode because you're typing in a radian. And it should match the negative square root of 3 over 2 decimal. So you can make sure those decimals match. You can check your work. Let's try the same thing for the next one. Our radian is 5 pi over 2, but it's negative. Let's first find the 5 pi over 2 radian value so we know where it's located, and we want to travel the same distance backwards. Can we find a 5 pi over 2 location? I see a 5 pi over 6, 5 pi over 4, 5 pi over 3. Is there a 5 pi over 2? Doesn't look like it. What do you think that means? That radian value of 5 pi over 2. It's not written on the unit circle, but it's still a radian value. It's still an angle measurement. What do you think that means? Yeah.
It's not 1 to 45 triangles from 60.
It might not be, okay, but it also might represent how we went more than one rotation around the unit circle, okay? So all these numbers and ordered pairs we wrote on here are just if we were to do one full circle. We talked about how we can do multiple circles. We can find coterminal angles that would land in the same spot. So this one is more than 2 pi. It's more than one circle. If you do 5 divided by 2, that's more than 2. Okay, so you went more than 2 pi around the circle. Let's go ahead and figure out a coterminal angle. Maybe we'll note that down here. If an angle is not found on the unit circle, find a coterminal angle. Okay, that is found on the unit circle. Can we think about how we found coterminal angles in the last section? How do we figure out where, or another angle that would land in the same spot? Yeah?
Change that back to a degree and subtract 360.
Okay, we can convert it to a degree and add or subtract 360. Could we keep it as a radian though? You could do that. What if we wanted to keep it as a radian? What would we have to add or subtract? What's the same as 360? Yeah.
We should do pi over 180.
That would be if you wanted to convert it, the pi over 180. If we normally add or subtract 360 if the angle is a degree, what do we have to add or subtract if the angle is a radian? What's equivalent to 360 in a radian? Yeah, 2 pi. All right, so you could convert it, no issue there, but we could keep it as a radian and just add 2 pi. Let's go ahead and figure out our coterminal angle. Now you are working with fractions, so you would need to get a common denominator. This would be 4 pi over 2. So negative 5 pi plus 4 pi would be negative pi, and we'll keep the common denominator of 2. Is pi over 2 on the unit circle? Where's pi over 2 located? Can we find it? Seems to be at the very top, right? Okay. So we're traveling a distance of 5 pi over 2, but since it's negative, that means we want to go backwards. So if we traveled positively, we would land at the top. Where would we land if we traveled backwards? What radian value? Yeah? 3 pi over 2. We'd land at the very bottom. Okay, so this is the same as tangent of 3 pi over 2. That's where we would land. That's our coterminal angle. That's on the unit circle. So we're going to go ahead and use that ordered pair to help us with this value. How is tangent related to x and y? Right? It gets y over x. So let's go ahead and take that ordered pair. We need the y value of -1 divided by the x value of 0. But -1 divided by 0 would be undefined again. We doing okay? All right, if an angle's not on the unit circle, you got to find a coterminal angle that is on the unit circle to help you out. Let's keep that in mind for these other ones. Do we have an angle of 3 pi on the unit circle? No, because it only goes up to 2 pi. So we either need to add or subtract 2 pi to get an angle that's on the unit circle. If we were to add 2 pi again, that would be -pi. So let's find pi on the unit circle. All right, that's on the very left-handed point. So instead of traveling positively to get there, we'd have to travel negatively the same distance. But notice how we would land in the same spot. Okay, so this is equivalent to -2 cosine of pi. That's where we would land. Even though we're traveling negatively, we actually end in the same spot in this case. Let's think about the next one. -pi over 4. If we were to travel backwards, pi over 4 angles or points, where would we land? Can you find it? Yeah. 7 pi over 4. Good. All right, so we're going to use those unit circle values to help us with these trig expressions. So we need -2 times the cosine value at pi. Cosine is the x-coordinate, so based on the ordered pair at the pi location, the x-coordinate is -1. Next, we need the cotangent value from the pi or 7 pi over 4 spot. How is cotangent related to x and y? Yeah? X over y. All right, so let's go to the 7 pi over 4 spot. We need the x-coordinate divided by the y-coordinate. Can we think about this one in our heads? If we took a positive square root of 2 over 2 divided by a negative square root of 2 over 2, what would we get? Yeah, -1. You're dividing the same number, so it's going to just simplify to -1 in this case, because one of them was negative. So it looks like we have 2 minus 1, which is 1. All right, maybe we'll check this one on our calculator because that was a kind of an easy value to find. On our calculator, we could type in -2 cosine of -3 pi. But I don't have a tangent button on my calculator. Yeah.
What do these numbers mean? What are they for? Once you get that one.
What's it tell you? Okay, so when you are figuring out a cosine or sine or tangent value, if you think back to the relationship to a triangle, you are figuring out a side length. So if we're figuring out an x-coordinate, we know how far this distance is. If we're figuring out a y-coordinate, we know what this distance is. So it's just the location on the unit circle. We're going to talk about how trig is used to model certain, they're called periodic functions, like waves of graphs, and we can utilize these trig values to help us make sense of those. So right now we're just working on the math behind it, but then we're going to apply it in a few sections. Okay? That's a good question. All right, let's check our work. So -2 cosine of -3 pi. How could I type in cotangent on the calculator? I only have a sine, cosine, or tangent button. Yeah. 1 over tangent. All right, so we'll type in plus 1 over our tangent, and inside that tangent, I'll type in the negative pi over 4 radian. Looks like we get 1. All right, so you can check your work. Perfect. All right, we're going to switch gears a bit. Okay, instead of trying to find values on the unit circle, we're going to try to figure out where an angle might be located on the unit circle if we have some information about these trig values. So it always comes back to the relationships between sine, cosine, tangent, and the variables x and y. Okay, let's keep those kind of fresh in our mind. So if we were to draw an angle that had a cosine value that was greater than 0, meaning positive, and a tangent value that was less than 0, meaning negative, we're going to try to figure out in which quadrant, okay, or axis, because it could land on the y-axis or x-axis, where would this angle be located? So we don't really have numbered values to go off of, we just have signs to go off of, meaning positive or negative. So let's see if we can kind of think this through. If cosine is positive, which variable does cosine represent again, based on our relationships, in terms of the unit circle? Yeah, the x value. Okay, so if cosine is positive, that means the x-coordinate should be positive as well. Can we narrow down which quadrant we might be located in if we know the x value is positive? If you think about a coordinate system, yeah? 1 and 4. Okay, this is your positive x-axis, so that happens in quadrants 1 and 4. All right, so let's write that down. So for this one, cosine of theta represents an x value, and if x is positive, theta, meaning the angle, must be in quadrant 1 or quadrant 4. So we narrowed it down. I mean, we only have 4 quadrants to begin with, which isn't that many, but at least we narrowed it down. Now somehow, with the tangent information, we should be able to narrow it down to one of these 2 options. So let's think about tangent. I'll go ahead and draw this in here. How is tangent related to the coordinates for x or y? Yeah? Uh-huh. Yes, you do, but go ahead.
I actually missed those days.
That's okay.
But, how do you remember them? Like, is it like a trick, or is it just like memorization? Just like.
It's going to be strict memorization.
Okay.
Okay.
I was just.
That's fine. If you know the 3 of them, though, you know the other ones. Like if cosine is x, then secant is 1 over x, because it's the reciprocal of cosine. So you don't need to know all 6 of them. You can just know 3. All right. Can we think about tangent? How it's related to x or y? Yeah. Okay, so tangent on the unit circle is the y-coordinate divided by the x-coordinate. Now, if we know tangent is negative, that means this fraction must be negative. So one of those 2 variables is negative, because you can have a negative in the top of the fraction and the bottom of the fraction. Doesn't matter where it's located. Can we narrow down which one of those variables is negative? Yeah. Why?
Because we already said that the x is positive, so in order to get it to divide into negative, we have to have the y.
Exactly. Notice how this piece of information confirmed that the x value has to be positive. So if this fraction must be negative, that automatically concludes that the y-coordinate would have to be negative, because this is already reserved as a positive value. So we'll say tangent is y over x, and since x is positive, y must be negative. So we already narrowed it down to quadrants 1 and 4 based off the cosine information. Of those two quadrants, 1 or 4, which one has y values that are negative? Yeah, 4, right, y values negative that are down here. So notice how we completely box in quadrant 4 with those two pieces of information. So we'll say theta is in Q4. All right, let's try B. Kind of similar because we're still dealing with cosine and tangent, so we can use kind of the same relationships. Cosine is representing an x value, and this is telling us that if cosine is positive, then the x value must be positive. So which quadrants are we, or could we possibly be in with that information? If x is positive? Didn't we say Q1 and Q4 from before? All right, let's try the next one. So tangent, we said, was y over x. This time, there's telling us tangent is undefined. So in terms of a fraction, what would make a fraction undefined? Yeah. So x equals 0 in order to be undefined. If x is 0, where are we located? Yeah. The y-axis. Can you take a look at those two statements and think about where this angle might be? This one's kind of a thinker. Say it again. Read this one?
Yes.
Oh, that's on. I'm sorry. On. Yep. The first one's telling us that the x value must be positive. The second one's telling us that the x value must be 0. Can those two things happen at the same time? Can you have something be positive and 0? No, okay? So that's what that's telling us about this particular angle is that we can't draw it. It's not possible to draw an angle on the unit circle so that the x value is positive, but the x value is also 0. Okay, it's not really checking out once we analyze those relationships between x and y. So there is no theta or angle that exists. All right, let's try C. Tangent, that's our relationship of y over x, and it's greater than 0, meaning positive. So can we think about what that might mean in terms of our x and y? In order for a fraction to be positive, what must be true about that fraction? Maybe think about numbers. What are some numbers you can divide together that would give you a positive answer? Yeah. Okay, so what was your first part? Could they both be negative? Okay, so they either both have to be negative, right, because a negative divided by a negative is a positive, or they both have to be a positive. All right, so x or y and x have the same sign, meaning they're both positive or negative. And I love what Tori threw in at the end, and x cannot equal 0, right, because that would make the fraction undefined. Okay, so at least we know x and y have the same sign. Can we think about what quadrants that might be true in? Where do x and y have the same sign? Yeah.
Quadrant 1 and 3.
There we go. So quadrant 1 or quadrant 3. So we narrowed it down. Let's take a look at the cosecant. How is cosecant related to x or y? Yes?
1 over
1 over y. All right, so they're telling us cosecant has to be negative. So that must mean y is negative. Which quadrant is y negative in? I see that would be Q3 or Q4, the bottom two. So can we narrow it down to which quadrant this angle would lie in if it had these two properties? Do we notice an overlap? Do we see how both of them had Q3 in them? Okay, so this angle must be in quadrant 3. We don't know where it is in quadrant 3, we just know it is in quadrant 3 based off that information. All right, let's try D. Sine is negative, so if sine is a y value, that means y is negative. So which quadrant might we be in for that piece? We thinking Q3 or Q4? Okay, y is negative. Let's try secant. How's that related to x or y? Yeah.
1 over L.
1 over x. All right, so secant is undefined. So that must mean x equals 0. If x equals 0, then the angle is on the y-axis. All right, so can we think about, in terms of a graph, where is a y value negative, but the x value always 0? Can you think about a graph? Where the y value is negative, but the x value is 0. Let's see. For the first one, we said we're either in quadrant 3 or quadrant 4. So we know we're somewhere down here or somewhere down here. And the second one said we are on the y-axis. So the question is, are we on the left-handed are we on the positive y-axis or the negative y-axis? If you have to be down here, where are we located? Yeah? The negative y-axis, somewhere down here, right? We're either in quadrant 3 or quadrant 4 and on the y-axis, so that only leaves this part of the y-axis for us to consider. So theta is on the negative y-axis. So you would be on like the very bottom of your unit circle, that 270-degree point or that 3 pi over 2 point. Okay, we're at the very bottom, that negative y-axis. All right, let's just try our last one here. Suppose that our angle is between pi over 2 and 3 pi over 2, and we know the sine value is a half. What is the value of theta? And determine the exact value of the other 5 trig ratios. All right, so let's just kind of figure out which quadrant we might be in first. Can we narrow it down based off of this information? If you have an angle between pi over 2 and 3 pi over 2, which quadrant or quadrants might you be in? What do you think, Tori? Say it again. Well, let's check it out. Okay, so pi over 2 is at the very top, 3 pi over 2 is at the very bottom, and we trace our unit circle in that counterclockwise direction. So if you start here and end here, and you're tracing this way, do you notice how it covers quadrants 2 and 3?
So it wouldn't change anything. I guess they're not negative. So I just didn't know if it would go. If there's any way to go.
Not necessarily negative. They're just telling us we're basically starting at 90 degrees and we're ending at 270. If you want to think about degree measurements instead. Okay, so we're going to be somewhere in quadrants 2 or 3. Okay, this is kind of giving us a domain or an interval, like a beginning point and an ending point. So Q2 or Q3. They also are telling us that the sine value, aka the y value, is a half. So if you take a look at the unit circle, just in those 2 quadrants, can we find a point that has a y value of a positive half? Which angle are we located on? Can we find it? If we have a y value of a half? Yeah? 5 pi over 6, or 150 degrees. All right. So theta is 5 pi over 6. Okay, there's our value for theta, because that was specifically in between or in quadrants 2 or 3. With this information, we want to determine what the other 5 trig ratios would look like. So let's take that ordered pair from that point, and we're going to figure out the cosine value, the tangent value, and then all the reciprocals. So we already know the sine value is a half. What would the cosine value be based off that ordered pair? Wouldn't that just be the x value? All right, let's go ahead and try tangent. For tangent, we have to take the y coordinate divided by the x coordinate. So we'll have 1/2 divided by negative square root of 3 over 2. Instead of dividing by a fraction, you can move it up and multiply by the reciprocal. The 2's would cancel out, and we're left with a negative 1 over square root of 3. But we don't want to square it in the denominator, so we'll go ahead and multiply by that square root. We'll get negative square root of 3 over 3. All right, so we know sine, cosine, and tangent. It should be pretty easy for us to now figure out the reciprocals. Let's try cosecant first. So for cosecant, we need the reciprocal of sine. If we were to flip 1/2, we would get 2. Let's try secant. Secant's the reciprocal of cosine. So if we were to flip cosine, we'd get negative 2 over the square root of 3. But again, notice how we have a square root in the denominator. So we will get rid of it. We'll have negative 2 square roots of 3 over 3. And our last one is cotangent. We have to flip tangent. Now here's the thing with this one. You could flip the final answer that we had, negative square root of 3 over 3, but you could also flip this one, because these technically are the same thing. Notice how if we flip the negative 1 over square root of 3, that would just be a negative square root of 3. You would get the same answer in the end if you flipped this one, but if you flip the final answer, you'd have a square root in the denominator, so you'd have to get rid of it again. So a little shortcut, you could use the previous one. Okay, so once we know an angle or the quadrant it's in, we could possibly figure out the other trig values as well. Okay, we're going to do much more of this next week, particularly finding the trig values and figuring out which quadrant or axis we might be on. So this is just kind of an intro into the next section. Okay, we will stop there. On our test day, which I'm not sure when that would be yet.
Okay.
We still have 2 more sections to cover, and then a quiz, and then the test.
Okay, good. So I started doing homework and I realized I have no idea of anything that we did for the first half of the session.
But okay, it'll come back because we're gonna do. I know you missed a day or two, but we're gonna keep looking at examples of these.